really think that junk can run again?
Machines don't lie. No way. What if every one of them is still alive?
This is impossible.
No, they never failed. Those engines were never inspected properly. 3 people flagged the control modules.
Nobody was allowed to touch them. Someone wanted those engines destroyed.
Then this was never an accident.
We're losing half the system.
Watch what happens next.
How is that possible?
They called them dead.
Everyone laughed when Isaiah Booker asked to take the 6 engines that Ashbourne Dynamics had declared dead weight. They had defeated 3 separate engineering teams, consumed hundreds of thousands of dollars in failed diagnostics, and spent 8 months gathering dust behind a chain-link fence on the far side of the property. Preston Blackwell joked that the single father was hauling 6 steel coffins back to bury alongside his failing garage. Isaiah said nothing in return. He pressed one hand flat against the first engine block, turned the crankshaft slowly with a wrench, and simply listened. 6 weeks later, the same people who had laughed stood completely silent, while all 6 engines fired up together. Stay until the end, because those discarded engines were hiding a secret worth several $1,000,000. The morning Isaiah Booker drove his pickup through the front gate of Ashbourne Dynamics. He was not there to make history or prove anyone wrong. He was there because a hydraulic seal on an industrial forklift had cracked, and the repair job was small enough that most shops had passed on it. But Isaiah needed the money badly enough to take anything that came through the door. Booker Mechanical Works had been operating on the thinnest margin for nearly a year, caught between rising equipment costs and a town that had watched too many of its manufacturing contracts dry up and blow east. He worked the forklift repair quickly and cleanly, the way he did every job, without ceremony, without asking for approval, because the work itself had always been the one thing in his life that answered back honestly when he asked it a question. While he waited near the loading dock for a plant supervisor to sign off on the work order, Isaiah noticed something through a gap in the fence line. A row of shapes parked in the gravel lot beyond the main building, covered in blue tarps that had started to sag and split at the corners. He counted 6 of them, and even from that distance he could tell they were large. Industrial scale, the kind of engines that belonged inside a serious generator frame, and not rotting in a gravel lot. A nearby maintenance worker told him without much interest that those were the prototype units from a shelved power generation project, that they had failed every load test the company put them through, and that the paperwork to have them scrapped had been sitting on someone's desk for months. Isaiah walked closer without asking permission, which was the kind of thing he had always done, and which certain people had always found irritating about him, and he crouched beside the nearest tarp and lifted one corner just enough to see the engine block underneath. The exterior surface was dirty, but not corroded in any serious way, and the inspection seals along the valve cover and oil pan were still intact, which meant, as far as Isaiah could tell standing in that gravel lot, that no one had actually opened the engine to look at what was inside. Colton Vance, the plant's lead engineering technician, appeared at his shoulder a few minutes later and told him with the practiced confidence of someone who has learned to talk loudly about credentials, that 3 separate diagnostic teams had looked at those units, that the internal damage was extensive, and that the cost of teardown alone exceeded the scrap metal value. Isaiah did not argue with Colton, did not pull out a competing credential, or raise his voice, because arguing was not how he worked. He just asked quietly whether anyone had physically pulled the oil pan on any of the 6 units, and Colton's answer, which came just a half beat too slow, told Isaiah most of what he needed to know. When the plant office informed Isaiah that their accounts payable department could not release his full invoice until the following billing cycle, a delay of nearly 3 weeks, he made a proposal so calm and so strange that Colton actually looked over his shoulder to see if someone was filming the moment. He asked to take the 6 engines in exchange for the outstanding balance, with the understanding that he would transport them off the property within 48 hours and sign whatever paperwork the company needed to formalize the transfer. Preston Blackwell, who had come down to the loading dock to handle the situation personally, and who had his own reasons for wanting those engines gone before the next quarterly audit, agreed before Isaiah had finished the sentence. He even smiled when he said it, the kind of smile that lives at the edge of contempt, and he said that the man was welcome to haul 6 steel coffins home to bury beside his business. Isaiah signed the transfer document without reading it the way a nervous person reads something. But he read every line before he signed, and then he tucked the copy into the front pocket of his work shirt and walked back to the engine that was nearest to the fence. He crouched beside it, fit the wrench to the crankshaft stub, and rotated it slowly, and felt, in the resistance and the release of that motion, something that did not feel like a dead machine at all. The logistics of moving 6 industrial engines on a budget that barely existed required Isaiah to call in most of the favors he had left in this town. And by the end of the first day, he had borrowed a flatbed from a friend who ran a salvage operation 2 miles east, recruited 3 former co-workers to help with the loading, and spent nearly everything left in the Booker Mechanical Works operating account on fuel and rigging hardware. His landlord, a man named Gerald Pruitt, who had been patient for longer than his lease required, met Isaiah at the garage that evening and reminded him, in the flattest possible terms, that the balance owed on the property was not going to wait another month, that this was the last conversation they were going to have about extensions, and that the garage would be padlocked if the payment did not arrive by the 30th. The neighbors on the block had opinions about the 6 engines the moment they arrived, and those opinions were not charitable. 2 of the older men on the street stood at the edge of their driveways and watched the unloading process with the particular silence of people who are saving their commentary for later and louder audiences. Lena Booker appeared at the side door of the garage that first evening, while her father was still unhooking straps from the last engine, and she did not ask whether he could fix them, did not ask what they were worth, but asked instead why he believed they had not actually died. Isaiah stopped what he was doing and gave her an honest answer, the same answer he gave every mechanical problem before he opened it up. He told her that machines do not lie, that when something is truly broken at the core, it leaves evidence in the metal, in the heat signatures, in the wear patterns, and that these 6 had not left any of that evidence on the outside. He told her that whatever had stopped them from running felt more like a command than a collapse, the difference between an engine that burned itself out and an engine that was told to stop and obeyed. Lena went back inside without further comment, which was how she had always processed the things her father said. She carried them with her and turned them over quietly, the way he turned over machinery problems in the hours before sleep. Late that night, alone in the garage with a drop light and a rolling stool, Isaiah pulled the oil pan off the first engine and held it under the light, tipping it slowly to check the residue at the bottom. And what he saw, or more precisely what he did not see, was the thing that made him set the pan down and sit still for a full 2 minutes before he continued. There were no metallic particles of the size or distribution that accompany internal mechanical failure, no scoring on the bearing surfaces, no discoloration at the piston skirts that would indicate thermal damage from a true overrun. The report that Colton Vance had signed, the one that Isaiah had read carefully in the office, described extensive internal damage to multiple units, but the first engine he opened was clean enough that he could have reassembled it and started it that same night if he had known what had been sending it false signals. He called Tessa Holloway at 11:30, which she later told him she considered unacceptably late for a phone call, and he described what he had found and sent her photographs of the control module, still bolted to the engine's intake manifold. Tessa had worked with Isaiah years earlier at a heavy equipment manufacturer in the next county, and she had left that job for the same reasons he had, because someone above her had asked her to approve documentation she did not believe was accurate, and she had refused. She was skeptical about the call, skeptical about the liability of touching hardware that had belonged to a major industrial firm. And she told Isaiah all of this before she looked at the photographs. But then she looked at the photographs, and she recognized the model number stamped on the control module housing. And she told him she would be there in the morning. Tessa arrived at Booker Mechanical Works before 8 the next day carrying a diagnostic interface and a hard-shell case of testing probes, and she did not say good morning so much as she set her equipment on the workbench and started asking questions. She and Isaiah worked methodically through the first engine, not trying to start it, not running it under load, but simply applying power to the control module and the sensor array while the engine remained cold and stationary, which was a protocol that most diagnostic teams did not bother with because it seemed too basic. The temperature sensor on the first engine reported 241 degrees within seconds of receiving power, despite the fact that the block was at ambient shop temperature, cool enough that Isaiah could rest his palm against it without discomfort. And the oil pressure sensor simultaneously reported a reading that would indicate catastrophic low pressure in an operating engine. Tessa pulled the calibration data from the control module and spent 20 minutes cross-referencing it against the engine's specification sheet, and when she looked up, she had the expression of someone who has found the answer to a question and does not quite like what the answer means. The control module had been configured with parameters from a different engine family, a smaller, lighter unit with lower operating thresholds, which meant that every time the large industrial engine reached its normal operating range, the control system interpreted those perfectly healthy readings as dangerous anomalies and shut everything down. This was not a difficult error to make in isolation, but it was an extremely difficult error to make 6 times in a row across 6 identical units without either extreme negligence or a specific decision to use the wrong hardware. A competent engineering team given the correct documentation could have identified and corrected this configuration mismatch within 2 or 3 days of focused work, which made the official report, the one describing irreparable mechanical damage, something far more troubling than a diagnostic mistake. Isaiah said he did not want to turn the garage into a corporate investigation, that whatever had happened inside Ashbourne Dynamics was their problem to eventually discover, and that his immediate concern was getting one engine running under real conditions. Tessa agreed with the priorities, designed a standalone test controller from components she had in her case and a second-hand microcontroller Isaiah ordered overnight, and the two of them spent the rest of that day on fuel line cleaning, gasket replacement, and injector calibration. The slow foundational work that no diagnostic software can do because it requires hands and judgment and patience. The first start attempt produced nothing, which Isaiah had expected. The second attempt ran for 11 seconds before the test controller triggered an overvoltage protection he had not yet calibrated properly. And the third attempt ran for just under a minute before a vibration that seemed to come from the engine itself shook the whole assembly. Isaiah stood still while Tessa checked her data, and then he walked around the test bench and pressed one hand flat against the base frame and understood immediately that the vibration was not coming from the engine at all. It was coming from the test bench, which was a welded steel frame he had built years earlier for smaller units and which was flexing under the torque output of something significantly more powerful than it had ever been asked to hold. He rebuilt the mounting that evening with heavier stock and additional cross-bracing, and the following morning the first engine ran for 20 continuous minutes at moderate load, without a single fault code, and the data was clean. Tessa sat at the bench, staring at the readout for a long time before she spoke, and when she did not celebrate. She said that no one accidentally installs the same wrong software configuration into 6 separate engines, and that whoever specified the control modules for this project either did not know what they were ordering or had a reason to order the wrong thing on purpose. Word of the running engine reached Ashbourne Dynamics before the end of the week, carried back by one of the technicians who had been on the loading dock the day Isaiah took the engines away, and who had mentioned it at the wrong moment in the wrong break room. Preston Blackwell arrived at Booker Mechanical Works 2 days later with Colton Vance beside him and a legal notepad in his hand. And he spoke in the measured tone of someone who has learned to make threats sound like reasonable business discussions. He told Isaiah that the engines contained proprietary design elements that remained the intellectual property of Ashbourne Dynamics regardless of the physical transfer agreement, and that any testing, modification, or commercialization of those units would expose Isaiah to significant legal liability. Isaiah produced the signed transfer document from the file drawer where he kept every piece of paper that had ever mattered and read aloud the paragraph in which Ashbourne Dynamics formally relinquished all claims to the physical assets, their components, and their material value. And then he asked Preston, in the same even tone Preston had used, whether the company intended to dispute a document that Preston himself had authorized. Preston shifted to a different approach and offered to purchase the engines back for $20,000, which was more than the outstanding invoice amount, and which he presented as a generous resolution. But Isaiah declined without hesitation because $20,000 would not cover the cost of what he and Tessa had already invested in diagnostics, labor, and replacement components, to say nothing of what he was beginning to understand about what the engines could actually become. Colton Vance, meanwhile, had crouched beside the engine that was still mounted on the test bench and was examining it with the particular focus of a person whose professional expertise is telling him something that conflicts with a report he signed his name to. He asked Isaiah quietly and without looking at Preston whether the core components had been replaced, the crankshaft, the block, the combustion chamber assembly, and Isaiah told him no, that what he was looking at was the original hardware from the factory floor. Something shifted in Colton's expression, not guilt exactly, not yet, but the first edge of a recognition that the conclusions he had certified were not based on evidence anyone had actually examined. Preston made a harder move then, telling Isaiah that the control software embedded in the original modules constituted protected code, and that using data extracted from those modules to develop new systems would constitute theft of proprietary technology. And Tessa, who had been listening from across the shop floor, walked over and opened her laptop and showed Preston a line-by-line comparison of her controller code and the original BKW17 firmware, which shared no common architecture and had been written entirely from scratch. After Preston left, Colton came back alone, on foot about 40 minutes later, and he stood in the garage doorway for a long moment before he walked in and said that there was something Isaiah needed to know about the control modules. He said the engineering team had flagged the BKW17 specification during the initial procurement review, that 3 different technicians had noted the parameter mismatch in internal emails, and that Preston had told them the modules had been certified by the supplier, and to close the matter and move forward. He said that when the engines began failing, he had wanted to pull and replace the control units as the first diagnostic step, and that Preston had specifically instructed the team to evaluate only the mechanical systems and not to touch the electronic controls. And then Colton said the thing that locked everything into place, that Preston had been pushing for the engines to be physically destroyed rather than simply decommissioned, and that the scheduled disposal date had been moved up twice in the weeks before Isaiah arrived. Isaiah did not say anything immediately because he was working through the shape of what he had just been told, fitting it against what he had found in the oil pan and what Tessa had found in the firmware. And he understood that the 6 engines were not just an opportunity. They were a record of a decision that someone with authority and a financial reason had made, and that the decision had nearly been shredded and melted before anyone could read it. The problem with simply repairing and selling 6 industrial engines from a small garage in Michigan was that the market for used prototype units without manufacturer support was approximately nothing, and Isaiah understood this before he had finished reassembling the second engine. No hospital administrator, no emergency services director, no commercial buyer of serious power infrastructure was going to sign a purchase order for 6 orphaned machines backed by a one-man shop and a handshake warranty. And even if they had, the revenue from 6 engine sales would not come close to what the project had already cost him in time, money, and sleep. He spent 2 evenings studying procurement reports and emergency management documents from the previous 3 hurricane seasons. Documents that were publicly available and that painted a consistent picture of the same failure repeating itself across region after region. A hospital or a medical facility running on a single large generator, and when that single machine failed, there was no fallback, no staged redundancy, no way to keep critical systems alive while the primary unit was serviced or replaced. Isaiah drew the configuration on a piece of paper first, the way he had always worked out mechanical ideas. 3 engines in a cluster, each connected to a common output bus, but with distinct roles assigned to each one, so the system did not try to share control equally and fight itself the way the first synchronization attempt had done. One engine would carry the baseload during normal operation. A second would monitor the bus and step in automatically the moment demand exceeded a set threshold or the primary machine showed stress. The third would stay in a warm standby state, ready to take over any share of the load within seconds if either of the first 2 dropped offline. And the 3 machines would rotate through those roles on a programmed schedule, so that no single unit accumulated disproportionate wear. Tessa told him the concept was sound, and that she could write the coordination logic, and then she told him they had no money, no test equipment of their own, no certification documentation, and no path to the safety approvals that any serious buyer would require before signing a contract. Isaiah sold the truck he had been using as personal transportation, liquidated a set of precision machining tools he had owned for 12 years and used on the jobs that paid best, and picked up 2 weeks of overnight maintenance work at a packaging facility in order to keep the household running without touching Lena's school expenses. He did not explain the situation to Lena in detail because she was 12 and because some burdens are not a child's to carry, but she noticed the truck was gone and she did not ask about it, which told him she had already understood most of it on her own. Tessa located a university engineering lab that rented test equipment by the hour to independent contractors, which was expensive but not impossible, and Colton, carefully, in ways that never involved transferring restricted documents, provided publicly available performance specifications for the engine family that helped Tessa calibrate the coordination algorithms without relying on proprietary data. The 6 engines came back to life one at a time over the following weeks, each with its own minor collection of problems accumulated during months of outdoor storage. A stuck injector on the 3rd unit, surface corrosion on a coolant fitting on the 5th, a sensor bracket that had cracked on the 6th, and each time Isaiah found the issue and fixed it without drama, because that was what he did. The lease deadline arrived with the first 3-engine cluster still untested at full load, and Gerald Pruitt sent the final notice in an envelope with his return address printed on it, which felt like a formality designed to feel more final than a text message. And Isaiah read it and set it on the corner of the workbench and went back to work. He had brought the coordination algorithm to a point where Tessa was confident it would perform, but they had not yet put all 3 engines under real load at the same time, and the first time they did, the system held steady for 40 seconds before the load balancing routine fell out of phase, and the cluster shut down in a cascade that left them both standing in a suddenly quiet shop with the smell of hot diesel cooling in the air. Isaiah did not sleep for the better part of 2 days after the synchronization failure, and at some point during the second night, Tessa sat down across from him at the workbench and told him plainly that she had known exhausted engineers to make errors that damaged equipment and hurt people, and that she was not going to let that happen in this shop. He went home and slept, and when he came back in the morning, he looked at the failure data with the slower attention that rest allows and saw it differently than he had the night before. The individual engines were not at fault, and the algorithm was not fundamentally wrong, but the load coordinator was trying to reach a consensus among 3 equal machines, and the tiny latency differences in each engine's sensor response time were enough to create a feedback loop where each machine kept correcting for what it thought the others were about to do. He had seen a version of this problem before, years earlier, when he had done contract maintenance work on a backup power system at a military installation in the northern part of the state. A system where the engineers had solved exactly this kind of mutual interference by assigning a clear hierarchy to the machines, so that one unit led and the others followed its signal rather than each trying to calculate independently. He described the architecture to Tessa, who took the idea and spent the next 18 hours rewriting the coordination layer. And when they tested the first cluster again, it ran through 2 hours of variable load without a single fault. The 3 engines moving through their roles in sequence with the unhurried efficiency of something that had been designed this way from the beginning. 2 days before the scheduled demonstration, a process server arrived at Booker Mechanical Works with a document from Ashbourne Dynamics' legal department alleging patent infringement and demanding an immediate cessation of all testing and development activity. Isaiah called the small business legal referral line he had found through a community development program, and through that referral he reached Eleanor Pierce, a patent attorney who happened to have spent 7 years doing intellectual property litigation for heavy industry firms before leaving to practice independently. Eleanor reviewed the filing overnight and called Isaiah the next morning to tell him that the patents cited by Ashbourne Dynamics covered specific aspects of the engine design and manufacturing process, and that Isaiah's coordination system, which was a software and integration architecture applied to hardware he now legally owned, did not infringe any of the claims. The filing would not hold, she said, but it would take time to formally resolve, and the uncertainty it created was enough to cause 2 of the facilities that had tentatively agreed to attend the demonstration to send last-minute cancellations. Dr. Grant Calloway did not cancel, because he had been through 1 season of emergency power failure at his hospital, and he was not willing to go through another. And he told Isaiah's contact that he would be there, regardless of what legal dispute a corporate law firm had decided to manufacture. The demonstration was scheduled for a leased industrial warehouse on the edge of town, and Isaiah and Tessa spent the day before it checking every connection, every sensor, every data cable, moving through the checklist with the methodical focus of people who know they will not get a second chance at this particular room. At 11 o'clock that night, working alone after Tessa had gone home to sleep, Isaiah found a signal cable on the 4th engine that had been cut cleanly through. Not frayed, not worn, not accidentally damaged, but severed with a sharp tool at a point where the cut would not be visible without moving the cable bundle aside. He photographed it, documented the location and condition, called the police to report the break-in, and then called Tessa, and they were both back in the shop by midnight replacing the cable and checking everything else with the kind of attention that comes from knowing someone has already been inside your work trying to break it. Dr. Calloway arrived the following morning with his chief facilities engineer and a representative from his hospital's insurance carrier. All 3 of them looking at the warehouse and the 2 3-engine clusters with the professional skepticism of people whose job is to evaluate risk rather than be impressed by ingenuity. Victoria Langford had seen a technical summary of the project through a contact in the infrastructure finance community, and had decided that it warranted her personal attention, which meant that when she walked through the door, she was already more informed about the system specifications than most of the people in the room, and she stood near the back and did not introduce herself to anyone except Isaiah, to whom she said only that she was there to watch. Evelyn Ashbourne had not been invited and had not asked permission. She had simply arrived because one of her vice presidents had told her that the company's discarded prototype engines were running in a warehouse across town, and Evelyn Ashbourne did not hear that kind of news and decided to monitor the situation from her office. Preston Blackwell was with her, along with Colton, and Preston stood near the front with his arms crossed and told the person standing next to him, loudly enough that it was clearly intended to carry, that the system would not sustain output above 70% load because the coordination software had not been built to handle real-world variance. The first test run was straightforward. a load profile designed to simulate a mid-sized medical facility during normal daytime operation. Demand rising steadily over 30 minutes, the second and third engines stepping in on cue as the load increased. All of it performing exactly as Isaiah had designed it to perform. Then the test committee asked Isaiah to hold the configuration steady while they introduced an unannounced interruption, and a technician from Dr. Calloway's team reached over and cut power to the lead engine. And inside 2 seconds, the second engine had assumed command of the output bus. The third had initialized and come up to partial load, and the instruments showed no break in the power supply. Preston said the failure scenario had been prepared in advance, that Isaiah had pre-configured the system to respond to exactly that sequence, and that a real emergency would not announce itself before it arrived. Victoria said the same thing, without the accusation in it, and asked whether the system could be tested against a scenario that Isaiah had not been given prior notice of. Dr. Calloway stepped forward and spoke quietly to his facilities engineer, who walked to the control panel and simultaneously cut 2 engines, one from each cluster, while a separate technician triggered a demand spike from the load simulator. The warehouse was loud for a moment, and then quieter than it had been all morning, as the remaining 4 engines reallocated the load among themselves in a sequence that no one in the room had specified, and that the coordination software had to generate in real time from a set of priorities that Isaiah had built into it, rather than a script it was following. The system held, and then it held some more, and the instruments stopped moving and settled at stable values, and the people in the room looked at the instruments and did not say anything for a long time. The 6th engine then flagged a fuel pressure anomaly. Not a catastrophic failure, but a reading that indicated it should be taken offline before the issue developed further. And Isaiah reached for the manual isolation control and pulled the 6th engine out of the network, while the remaining 5 machines redistributed the load without a single cycle of interruption. He had not planned for the fuel pressure warning and had not staged it, and everyone in the room could see that. And the people who had spent the morning looking for reasons to dismiss what they were watching found themselves instead looking at a system that had just been tested by chance and had answered correctly. Victoria Langford walked toward Isaiah as the noise in the room began to pick up again, and she asked how much it would cost to build 2 complete production-ready systems. Isaiah looked at her steadily and said that she was not buying engines. She was buying a design that ensured no single failure could take the whole system down, and that the price had to reflect what that guarantee was actually worth. Victoria Langford did not negotiate on sentiment, and she did not negotiate on the strength of a compelling demonstration alone. She sent her analysis team into the warehouse for 3 hours, while Isaiah and Tessa answered technical questions, and she had the contract structure ready before the end of the afternoon. The 2 complete production systems were priced at $1,600,000, which reflected the hardware, the integration engineering, and the testing protocol, rather than the scrap value of the components. The license for the coordination software architecture, the intellectual property that Isaiah and Tessa had developed independently, was valued at $650,000. Structured as a term license that gave Langford infrastructure capital deployment rights without transferring ownership. A 3-year maintenance and training contract added $450,000 more, covering ongoing monitoring, annual certification checks, and the training of facility engineering staff. An additional $300,000 covered the formal safety certification process, liability documentation, and the technical package that regulatory bodies would need to evaluate the system. Work that a certification engineer, Eleanor Pierce, recommended would begin the following week. The total was $3 million, and it was not paid in a single wire transfer on the day of signing. It was structured across production milestones and delivery stages, which was the kind of contract that serious institutional buyers preferred because it tied payment to verified progress rather than promises, and which suited Isaiah because it gave Booker Mechanical Works a revenue stream tied to real work, rather than a sudden windfall that could vanish the moment a problem arose. Victoria asked for a right of first investment in future Booker Mechanical Works projects, which Isaiah agreed to in principle, with a clause that the garage retained majority operational control, and that any expansion would be staffed with workers recruited from the local skilled trades community, rather than brought in from outside. Dr. Calloway signed a letter of intent to deploy the first completed system at his primary facility once certification was obtained, which gave the project a real customer and a real deadline, rather than a speculative future order. Preston Blackwell began objecting before the ink was dry on anything, arguing that Isaiah had commercialized technology derived from Ashbourne Dynamics research, and Evelyn asked her legal team to pull every document related to the BKW-17 control module procurement and the internal engineering review process that had preceded the decision to scrap the 6 engines. Colton Vance had been standing near the side wall of the warehouse for the last hour, and when Evelyn's assistant walked over and asked him to come join the legal discussion, he said he had something to send first, and he forwarded from his personal email account a chain of messages that had been sitting in a folder he had created specifically to preserve them. Messages in which Preston had approved the BKW-17 procurement from a vendor with whom he had a compensation arrangement, messages in which he had instructed the engineering team that the control units were not to be inspected as part of the failure analysis, and a message from 2 weeks before the scheduled disposal in which he had written that the engines needed to be gone before the third quarter financial review. Evelyn read the messages on her phone standing in the middle of the warehouse, and when she was done, she turned to Preston and said, in the quietest voice she had used all day, that he had called those engines scrap to protect a contract, and that she wanted to know how many other things he had declared worthless for the same reason. The internal review at Ashbourne Dynamics began the following week and proceeded with the particular thoroughness that organizations apply when they are trying to determine how deep a problem runs and whether they have time to address it before someone else determines that for them. Preston Blackwell offered 3 different versions of the BKW-17 procurement decision across his first 3 interviews with the investigation committee, and each version assigned more of the responsibility to the original vendor and less to himself, but the financial records did not share his flexibility. They showed a payment arrangement with the control module supplier that predated the procurement by 18 months, and that had been structured through a consulting entity registered in a state Preston had never visited. He was placed on administrative leave. At the end of the first week, his credentials were suspended, and the file was forwarded to the State Financial Crimes Unit before the month was out. His departure from the company was not announced with drama or ceremony. It was processed through the human resources system the same way every departure was processed, and by the time the documentation was complete, he was simply gone, which was a kind of justice that did not look like what people expected justice to look like, but which was thorough in its own quiet way. Colton Vance met with the investigation committee voluntarily and told them everything he knew in the order he had come to know it, including the moments where he had chosen silence over objection and the professional calculation he had made each time. Evelyn did not offer him absolution. She told him directly that silence had a cost and that he would need to rebuild his professional standing through demonstrated honesty rather than receive it back as a gift. But she offered him the opportunity to participate in the corrective process, which was a harder and more useful thing than forgiveness. Evelyn met with Isaiah privately at a conference room in a building 3 blocks from the garage, and she told him she wanted to acquire Booker Mechanical Works entirely and bring him in as Director of Research and Development for Ashbourne's Power Systems Division, which was an offer that came with a title and a salary and resources that the garage could not generate on its own. Isaiah told her no, and he told her why, in the same direct and unheated way he had said everything else throughout this entire situation. He said that the last time he had worked inside a corporate structure, the structure had asked him to sign documentation he knew was false, and that when he refused, the structure had found a way to make him unnecessary. and that he was not willing to trade the autonomy he had built for a position that would ultimately be defined by someone else's agenda. He said he would sign a long-term supply and technical collaboration agreement with Ashbourne, on the condition that the company implemented a formal channel through which any technician at any level could raise a safety or compliance concern directly to the board's audit committee without being filtered through department management. Evelyn agreed and said that was something the company should have had before any of this happened, and Isaiah said that was exactly the point. The first milestone payment from the Langford contract cleared 3 days later, and Isaiah used it to pay the full outstanding balance on the garage lease, purchase a proper engine hoist and alignment bench, and call 2 men he had worked with at the manufacturing plant years ago. Men who had lost their jobs around the same time he had, for reasons that were similarly difficult to explain without using the word retaliation, and offered them positions at a wage he had calculated carefully against what the maintenance contract revenues would support. The old sign above the garage door had been weathered down to a pale version of its original color, and Isaiah took it down one afternoon and did not replace it with anything elaborate. He mounted a new sign in the same dimensions, same font, same name, and added a single line underneath that read Power Systems Division, because what he had built deserved to be described accurately, not celebrated. 1 year after the day Isaiah Booker drove through the gate at Ashbourne Dynamics to fix a hydraulic seal on a forklift, 2 completed power generation clusters were installed in the utility sub-basement of Dr. Calloway's regional hospital, properly certified, fully documented, and connected to a monitoring interface that sent operational data to Booker Mechanical Works every 6 hours. The installation went smoothly enough that the facilities team was running it independently within a month, which was what Isaiah had designed it to do, because a system that required its builder to stay close was not a finished system. The test the design had been built for came on a Tuesday night in late autumn, when a storm with enough sustained wind to take down 3 distribution lines in the county pushed the regional grid offline for 11 hours across a wide area that included the hospital, 2 nursing facilities, a blood bank, and a water treatment pump station. The Booker system initiated its startup sequence automatically as grid voltage dropped below threshold, and by the time the main utility disconnected, the facility was already running on its own power. The load coordinator distributed demand across the 2 clusters, prioritizing the surgical suite, the intensive care unit, and the pharmacy cold storage in the way it had been programmed to prioritize them, while secondary systems like administrative areas and outpatient wings received power on a managed rotation. Engine 6 of the second cluster flagged a humidity-related sensor drift around 3 in the morning. Not a failure, but a reading that the coordination logic treated as a potential precursor and addressed by pulling the engine from active rotation and replacing it with the warm standby unit without any interruption to the output. The nurse on duty in the intensive care unit noticed nothing. The surgical team finishing a procedure at that hour noticed nothing. The only person who knew anything had shifted was the overnight facilities technician watching the monitoring dashboard, and what he saw was the system doing exactly what its designer had said it would do. Not every engine perfect, but the whole system unbroken. Isaiah was asleep when it happened, and did not know about the storm until his phone showed the alert the monitoring system had sent at 3:14 in the morning. A routine notification, not an alarm. Just a record that Engine 6 had stepped down and standby had engaged, and the output had not varied by more than a fraction of a percent. He looked at it in bed and set the phone down and went back to sleep, which was a different thing from the nights he had spent awake, worrying about what would happen when the system was tested by something real. Booker Mechanical Works did not become a corporation overnight because of the Langford contract, and Isaiah had not designed the business to become one. He had designed it to be a shop that employed skilled workers who had been underestimated by the institutions that trained them, that built things that worked in conditions other solutions could not handle, and that operated with a transparency that he enforced personally because he had seen what happened in places where that standard was allowed to slip. Tessa was named co-architect of the coordination system in all public documentation and held equity in the licensing revenue proportional to the work she had put in. Because Isaiah had decided early in the process that a story about one man's genius was not the story he was telling. He was telling the story of a method, and the method required honesty about where the ideas came from. Colton spent the year rebuilding, slowly, as an independent technical auditor, specializing in exactly the kind of control system procurement review that might have caught the BKW-17 problem before 6 engines were written off. It was difficult work to find at first, but the reputation he was building was one he had earned rather than inherited, which gave it a kind of durability that his previous position had not. Victoria Langford asked Isaiah at the system deployment celebration whether he had a number in mind for what the business could be worth in 5 years. And he said possibly, but not before the design had proven itself in enough real installations, that the value was based on demonstrated performance rather than projected potential, because he had seen what happened when the numbers got ahead of the reality. And he did not intend to let that happen in his shop. Near the end of that afternoon, after the formal presentations were finished and the catering was being cleared away, a young technician, who had been hired by Dr. Calloway's facilities team, after reading about the project, approached Isaiah near the service entrance and asked him how he had known. Standing in that gravel lot with the tarps and the chain-link fence and the laughter of the people around him, that the engines were worth the risk. Isaiah thought about the question for a moment, the way he thought about mechanical problems. Not quickly, but not slowly either, just with the full attention the question deserved. And then he said that the question was never whether they were worth the risk, because risk was just the price of paying attention to something other people had already decided not to think about. He said the real question was whether anyone had actually looked carefully enough to know why they had stopped, and that when the answer to that question was no, the situation was still open. And open situations were the only kind worth entering. Somewhere across the city, in the sub-basement of a hospital that was still running on its own power, as the grid came back online, 6 engines cycled through their rotation in the quiet, unhurried way of machines that have been understood, 3 of them active, 1 stepping back, 1 stepping forward, 1 waiting in warmth for whenever it was needed. They had been called dead once, by people who had good reasons to believe their own conclusions and better reasons not to look too closely at what those conclusions were built on. They were not dead. They had never been dead. They had only been waiting for someone to listen to them the right way.